Hey there. What we're looking at today, we're kind of going to a new concept with fractions within this module. This one, we're moving away from multiplication, kind of, and looking at what starts out with the operation symbol of division. I've probably hinted to you a little bit about the parent method for dividing with a fraction and the idea of using what's called a reciprocal of the second fraction. And what we're starting with today is just to show you why it works that way. Um, so then you can see what that means. This is asking you to do some drawing so that you can see what's actually happening with it. So drawing a tape diagram and a number line to solve and then filling in the blanks that follow. So if you think about this, if I have 3 sandwiches and I want to break them into thirds, how many 1/3 pieces would I have if I happen to have 3 sandwiches? So here's a tape diagram. Here's a number line also. I'm just going to draw them at the same time. So that way when I make my vertical dividing lines, I can just lift my pen and bring it back down again. Here's one, I lift my pen and bring it back down again. So that way it's easier to see. They kind of match each other. So how many 1/3s can we get out of this? So I'm going to go ahead and change colors so that it's easier to kind of be able to tell what's going on. So if we break this into thirds, so we had 3 equal pieces and now we're breaking these 3 equal pieces into thirds. And then we want to think about how many of them, if I divide 3 whole pieces, because this right here is 3 whole pieces. This right here is 1 piece, 2 pieces, 3 pieces. And we have broken them up into thirds. We've divided them by 1/3. And so when we look at this, we go, okay, here's 1, 2, 3, 4, 5, 6, 7, 8, 9. According to that, there's 9 pieces that are 1/3 in size in all of this. If you look at this right here, there's 3 of them. Here's 3 of them. Here's 3 of them. And so if we kind of go back to that thing that I talked about, that this ends up being the parent style method, or what we refer to long-wise, standard algorithm. The standard algorithm kind of is easy to see with this whole thing of there's 3 in each, there's 3 here, that what's going on there. So when we talk about the standard algorithm, it's 3 and then we change it from divide to multiply. And the idea of the reciprocal means flipping, making this one do a somersault. So if it does a somersault, it ends up looking like that. And what's happening here? It's 3 sets of 3, which we also say, oh, hey, that's 3 sets of 3. Repeated addition, 3 plus 3 plus 3. 3 times 3 is 9. There are how many thirds in one whole? According to this, I see 3/3 in a whole. There are how many thirds in 3 wholes? 3, 6, 9. Or we could just count them because 1, 2, 3, 4, 5, 6, 7, 8, 9. If 3 is 1/3, so this right here, then what is the whole? 9. So that's why that kind of works that way, just to show you. I'm going to go ahead and move on and take a look at, we'll do one more. That one's thirds. Let's do one that's into fourths. Here we go. We'll take a look at this one. So this one, again, we have to start with a tape diagram. It asks us, and a number line as well, so you can see it in both ways. Tape diagram, number line. And we're going to make the lines. 1, 2, 3. 4 lines get you 5 pieces. And we're breaking it into fourths. So I'm going to change colors. So this one goes into 4 equal pieces. 1, 2, 3 here. 1, 2, 3 here. Do it again. There we go. We're moving right along, right? 1, 2, oops. That was only 2. I needed another one. 2, 3, 1, 2, 3. 1, 2, 3. 1, 2, 3. So there's 4 pieces in there. 1, 2, 3, 4 pieces in there. So we've divided each one of those. We started with 5 holes. If this was 5 holes, I had to draw a line so it points at the 5. There we go. 5 holes, and this one's 1, 2, 3, 4, 5. And there's fourths. There's 4 fourths inside each one of them. So there's 4 in here. There's 4 in here. There's 4 in here. We're figuring out how many fourths we can fit into 5 holes. How many fourths can we fit into 5 holes? And so that's where we think about this, and we go 4 times 5, and we get 20. Now, if you look at it with that standard algorithm method, let's see if that works too. We have 5 over 1, and we switch from dividing to multiplying. We take that second fraction, and it does a somersault. We use the reciprocal of it. That's going to be 5 times 4 is 20. So this matches as to what's happening here. If you're asking how many fourths can I fit into 5, or if I say 5 divided into fourths, how many of them will I get? I'll get 20 of them. There are how many fourths in a whole? There's 4 fourths in a whole. There are 20 fourths in 5 holes. So if 5 is equal to a fourth, then what is the whole? It's 20. This one's kind of a good little word problem. I like the idea anyway. A principal orders 8 sub sandwiches for the teacher's meeting. So here's your sub sandwich. Sub sandwiches. There's 8 sandwiches here. 1, 2, 3, 4, 5, 6, 7. So this is 8 sub sandwiches altogether. And she's going to cut them so that all her teachers can have some. The principal is going to cut them into thirds. So each one is going to be cut into thirds. So if you do that, then each one of these is worth 3, right? Without having to make all your lines, you know that you're going to get 3 thirds out of each one of them. And then we think about, okay, so if each one of those happens to be worth 3, 3, 6, 9, 12, 15, 18, 21, 24. So then there are 24 mini subs. There you go. All right, so here's your homework. Let's take a look what we've got here. Draw a tape diagram and a number line to solve, and then fill in the blanks that follow. I'm going to ask you to do just A. Do just A. Thanks. See you tomorrow.